Hello, I'm Susan Krumdijk, Professor of Mechanical Engineering, and you have found the Transition Engineering Podcast, where we talk about how to make the energy transition work. Oh, can we test it? This should work. We're used to it by now. Hello, we are here with Belen and Philip and me, Susan Krumdijk. We have been working on transition engineering projects, and we are going to share with you a example project. Do you think that's a good idea?
Yeah,
for sure.
Yeah, we've gotten around to the how and the why and all that good stuff, but it's time to do a project.
Yeah.
All right, the rule is you got to start a project with defining a system. You can't solve the world. Yes. The mega problems are climate change, resource scarcity, but you can't solve the world. So we're going to start with a problem, and we have to first make sure we've defined a system and that we know for sure it's a wicked problem. So we have picked heating, residential heating in Munich. Yeah? All right, so residential heating in Munich, this is relevant to us because we had winter here. Mm-hmm. And there were some pretty cold spells, and we were really glad that our amazingly well-designed German heating and housing worked great. How about it? Did you guys, do you live in an apartment that was comfortable during the freezing cold winter?
Yeah, I live in a multi-family home, so we had it very warm and comfortable in there.
Oh, wow. So you're in a single-family home?
No, multi.
Multi.
Yeah.
Multi-family. What does that mean?
Yeah, multi-storage, where multi-apartments.
Oh, okay,
so.
apartments. I got you. Okay.
So.
How about you, Belen?
Yeah, same for me. I was like in a building and it worked great.
Okay.
I didn't have to turn the radiators up that much.
Yeah. Right, and don't they kind of, like in my apartment, it was just warm. There was a handle on the radiator.
Yeah.
And you could turn it up or down, and often I would turn it up because I was cold, and then I'd come back after lecture or something, and it would be pretty darn warm in there, and I'd have to turn it down. And there isn't really an automatic control, is there? You just have as much heat as you want all the time.
Yeah, not in my apartment.
Yeah.
You have to do it manually.
Right. And I don't know if that's if that is a holdover from when buildings weren't very well insulated and you just had to be cranking the heat through them all the time. I'm wondering because we did some data searching on this situation of heating of residences in Germany, and we found that houses built before 1950 used 250 watts per square meter per year.
Oh, that's a lot.
Is that?
Wow.
Yes. And that gets a little better. You get up to about 200 watts per square meter for houses built in the 1970s and onward. Mm-hmm. But now the current standard is 50 watts. So 200 watts per square meter difference.
Isn't it kilowatts?
Oh, am I saying watts?
Yeah.
Okay, you're right. Kilowatts.
Yeah, it's kilowatts.
The miracle of German engineering.
Yeah. Watts per year. Oh, that's good.
Well, that would be good.
I'll take it.
I'm sorry, kilowatts.
Kilowatts, yeah.
Right, and the passive house. What do people reckon they can get down to with the full-on passive house design?
Like 15 till 20.
Yeah,
kilowatts.
And to a certain degree, they say maybe you don't even need heating, just the internal refrigerator, people, appliances can even heat the place.
Yeah.
So that's pretty amazing. So that's one to remember. If you haven't seen Passive House, it's spelled Passivhaus. Yeah?
Passive? Yeah.
Passive House.
Yeah,
German word.
German word, yeah.
I teach it in my class about building energy. And what it means is just really
well insulated.
Yeah, well, everything's controlled. The infiltration is really controlled.
Yeah.
The insulation is way higher than the normal standard.
Yeah.
So it is, I guess you would say, over the top, and possibly if you're not in a really cold climate, maybe it's a bit over the top. but for Germany, for Northern Europe, and the cost benefit, it's like the things that you're doing, you do need a larger wall construction to get that much insulation in. But, you know, that's an upfront cost if you're building a house that's going to last 600 years like you might expect it would in Germany because you're living in houses that old sometimes. Yeah. Why not? Then, oh my gosh, spend the extra grand now and just do it properly.
Yeah.
I have a term for that. Have I used it in our podcast yet?
I don't know.
I don't know.
It wasn't offensive, right?
I know what you mean.
Yeah. Germanity.
Oh.
Just do it right. No excuses. I call that Germanity.
No offense.
No, not offensive.
That's the way it
It
is.
is. It's the way. Right. So the problem, I would say, is that, what did we find out? That 60% of homes are in that at least 200 kilowatts per square meter per year. They were built before 1970. There's a lot of old houses built to a much different standard. And so there, I think you start to see that's when the radiator and boiler systems were developed. They were developed to meet those loads. Yeah. That's why they're huge and oversized and can crank out the heat.
Yeah.
Yeah, I see it.
That's true, yeah.
All right, so that's really our problem, is probably the older houses and what the heck to do about them. And how are you, well, do we have any unsustainability there? The unsustainability is that Germany right now for heat uses gas and oil mostly. Yeah. Gas has come in recently, works great. Oil, how much of that does Germany produce?
Gas and oil, not that much.
As in none.
Yep.
So you get your oil from the friendly folks in the Middle East, and you get your gas from the friendly folks to the East.
Yeah.
So that's, okay, not sustainable on a couple levels probably. Fine.
No, not at all.
So okay, do we have a wicked problem? We might. It works great, but it's not sustainable. Meets your needs, but it can't go on.
Yeah.
You know it must change, and you know what you want to change too, but how do you change that? That change is hard. So I think we got a wicked problem. Residential heating.
We do.
All right. I mean, yeah. All right, good. So we launch. We want to go back in time. That's our first step. And see what residential heating was like 100 years ago. So we did our research, and we looked, and what did we find?
Okay.
Do you remember what we found? Well, first thing we found was that an awful lot of the houses and flats that people are living in Germany right now, as we said, they were living in then, 100 years ago, they were there.
Yep.
And that was part of our wicked problem, was that we have these very old buildings. So we kind of know how those buildings were performing, but we also know 100 years ago, there were no radiators and boilers, and there was no oil and no gas.
Right.
So people were cold.
No.
No, they weren't.
I think they were colder than us.
Colder, yeah.
They definitely dressed differently.
Yep.
For sure.
They wore more layers of clothes. They wore wool. And from what we could find, it looks like they were using wood in Germany. Not so much. We found coal in England and in some other places, but it looks like wood in Germany. And Philip, you also found there was a crisis with the wood fuel supply at some point.
Yeah.
With Munich.
Yeah.
Yeah, they had cut down all of the nearby forest.
Yeah, right. That was the thing. Yeah.
Yeah, because the population was getting up there. It was climbing up.
Yeah, I was liking to go to the forest and saw it as a spiritual place or something like that. So they didn't want to cut the nearby forest, so they had to import it from further away.
Right.
But not that far away. We do it now.
Right. So they were floating logs.
Yeah,
down the
river,
into the city
in Munich.
Right, but then all of the forest that they could use for wood around the Isar, they sort of depleted it and needed to build railroads to get the fuel into the city.
Right.
So we have definitely found wood burning stoves and a huge variety of them. It's just really impressive. All the I don't know how many wood burning stove manufacturers there must have been, but we've just found so many designs, and they were amazingly beautiful. People had them as part of their decoration in their house. They were really nice. So, but what we did find is that would be in probably one room of the house. And we also found that they were cooking with a combined heat, mostly they were cooking, and that also heated the kitchen area. So that wasn't a huge surprise. Another thing to know is that, so you've got your fuel supply flowing into the city, and in the countryside, people would use their own wood resources, cut it, stack it, and it would be left to cure for some years. And so people had a big cultural part of the culture is cutting your wood and storing it and having your wood supply for that winter, knowing you're going to be able to keep warm and cook that winter. Yeah. And it's a really common thing with people who live in the countryside that way, the putting in of the wood supply.
The stacking and organizing. Yeah.
Now I do have to say, these are the Germanity level in the wood stacking around here is really high. Yeah, what beautiful wood stacks.
It has to be perfectly organized and stacked.
Yes, and the wood,
no time for air.
Exactly the same size. No, if you haven't seen it, when you're in Bavaria, look for the wood stacks. They're amazing. Right. So we've learned something by going back in time. That you can deplete your resources even when there's not nearly as many of you as there are now. People did use wood. It works. We really couldn't find things about air pollution that, I don't know, just nothing came up. But using wood can be polluting, except the German design of the fire is really pretty interesting. It's quite efficient. It really takes most of that heat out of the wood, uses it for different things, uses it for baking bread, for boiling water. It goes through this big ceramic housing. It's a really good design. So it's possible maybe the air pollution wasn't too bad. Yes, we definitely found that people were cooking with it. All right, so as we move forward in time, we see that, like I said, there was a pretty steady pace of population growth until World War I, kind of a falling off, as you might guess, and then a climbing back up much slower than it was before, a plunge during World War II, and then 1950...
just got rapidly up.
That's right. So we're talking about Munich in specific. Munich is about less than 2% of Germany's total population. It's 1.4 million people in the city. And that city was growing gangbusters. It went from about 750,000 people in 1950 to pretty close to what it is now by 1975 to 1.3 million, 1.4 million.
Yeah.
So that is just an amazing growth, a doubling of population in 20 years. Right. And then we don't know why, but there was a decline in population, back to less than 1 million. And then since 2000, we've been back on a pretty steep ramp upward in population.
Yeah.
All right. So in the 1950s, about the same time we're talking about is this population boom, we decided to consider a company called Hoval, and they're a worldwide supplier of heating equipment for buildings and for residences. And in 1942, they launched a boiler product that heated hot water. We also found out that 100 years ago, people were heating up water, like enough to take not a luxurious bath in, but to wash with, and it would be on that same wood stove.
Yeah.
So Hoval's innovation was to separate those two, to have a separate water heater, and to use oil.
Yeah.
So you have the tank that you're all familiar with, the hot water cylinder. You have a flame underneath it. The flame has a control that it turns on and off. Probably the first ones didn't have that control. Probably you had to light up the boiler, get it hot. The boiler has a thermometer on it, so you can tell when it's up to temperature and turn it off. And by the time you have electronics, you can put a control on that. And by not that long after, by the 1950s, you start to see that boiler technology now moved into heating homes as well.
Yes.
So you have plenty of access to oil. You start to see radiators going into those old buildings that didn't have radiators. And I think that's where our 250 kilowatts per square meter becomes influential in the design of the heating equipment. Because they have to deliver a lot of heat.
Exactly.
And they can. The oil isn't that pricey, and you can have a nice, comfortable
As
house.
you see in your apartment, you can crank it up. Like
Yes.
even you can make it to a sauna.
You can. And you can dry your clothes and all that good stuff. So right now we've got 40 million people, there's 40 million apartments and 19 million residential houses, single family homes in Germany. Those single family homes use a lot more of the energy than the flats do, for probably obvious reasons. So we'll sort of, in Munich, we've got, I would say the vast majority of people are living in the apartments. Yeah. They're 5-6 stories high at the most, probably. There's not a lot of towers going on here. We have a lovely
traditional
city of Munich. Yeah, pretty traditional. Yeah. And the flats aren't small. They're
in average like 85 to 90 square meters per flat. Yeah. And mostly there are living two people in there. Right.
So it's not while it's a high density city, it's not a cramped living condition. All right. So we've got about 460 terawatt hours a year of residential space heating that we're looking at as our wicked problem we've got to deal with, because that needs to change. That's, like we said, mostly comes from oil and gas. And if we look into the future now, we're gonna look at scenarios. So right now, Germany has the Wärmewende. Did I say it right?
Wärmewende. Yeah.
Wärmewende. Okay, sorry. Which is the government's plan to change from oil and gas to renewables.
Yep.
And they have. If you look at the data for Germany, you see that the oil use since the 90s has been dropping, except for the last couple of years it's creeped back up a bit. And the gas use really shot up, probably replacing the oil. Has been a bit flat throughout the 2000s and started to drop off even after the global recession and the high oil prices, but has the last couple of years has shot up again. So there we are, our pathway to Wärmewende. It's not quite clear whether we're already on that pathway. It looks like probably not. So the heating degree days, in case you're on that side of the nerd spectrum, is over 2,000 heating degree days in Munich. That means during the winter heating season, it is cold here.
2,000 heating degree days,
Yep. It's a cold place. Now, you got the summer. You don't need to heat in the summer, but you do have a heating season, and that'll be definitely by November you're into it. It starts around October, and by May you're starting to get out of it. But that's a pretty good heating season. So we do need a lot of heat. Unless we have a passive house, and it's looking a bit better. All right. So the Wärmewende says, okay, let's the technology change basically is also an efficiency change. Let's refurbish houses.
That's what
good idea.
That's what you gotta do,
So if you look at the refurbishment of houses in order to meet the targets of an 80% downshift in fossil fuel use, the target that the government has set is 1 million refurbishments a year for the next 20 years. This is the scale of that problem, the magnitude of it. It's huge.
That's pretty huge. That's a lot.
That's a lot.
Yeah.
What do you do with that million people while their houses are being refurbished?
Yeah.
How do you pay for that?
Yeah.
Where do you get that many materials? Oh, that's probably not a problem. Germany
Yeah.
can do that. How do you get the people to build it? So that now, to be fair, that is about the same scale on which all that housing was built in the first place. So it's doable. Again, the question of how leaves us hanging. And we can definitely see that we are not already on that pathway, that something else needs to happen to get us there, that we're not on the pathway to meeting the targets. There's a 2020 interim target and then the 2050 target. So as far as technologies go, switching to renewables is the government policy for the Energiewende and the Wärmewende.
That's good. Pretty good.
So we did a little calculation. Definitely you can heat with wood, not a question. And actually we can heat with wood so much more efficiently than they did 100 years ago.
Yeah.
Sure.
We've got manufactured wood fuels. We've got wood pellet burners that are very clean. So huge potential there. Our fossil fuel space heat that we want to switch to renewables is 314 terawatt hours a year. Currently, Germany's using 75 terawatt hours per year, and it looks like that is not really a sustainable level of fuel use of wood. The forest management is not considered, about a third of it's considered sustainable.
Yeah.
So to increase the wood fuel use by more than 4 times, I think you'd be having to look at asking Indonesia to cut down some more of their rainforest, or it just doesn't look sustainable to do that, even with this improved efficiency. So while fuel for our heat from wood is a possible thing, not to replace that 314. So what we see is that the technology is going to have to go together with the refurbishment.
Yeah.
They might be compatible together, but it's going to be tight. What about solar heating? We love that in Germany. One of our favorites.
Yeah.
Philip's going to have to go here pretty soon. Sorry, he's got to go on to an exam practice. And I wanted to get to your family's example. What we see if you look at the heating degree days and the solar days, they don't match. That shouldn't be a surprise for people in the northern climates. So being more efficient is good. The boilers in Germany are already quite efficient in the heat transfer.
They are.
But are they efficient in the use of the fuel? That's the question we're starting to have. It's a bit of a disruptive thought. And how are people going to choose not to use fossil fuel? Those are our 2 big questions. So, Philip, if you could give us a quick rundown. Your family has done a refurbishment.
Yes, we did. So we had to, or we like to increase the size of our house. So we did a construction, and in fact we lived in the already existing house, and the construction was right behind the house, and we changed the size by building like a small new house behind the house, and then breaking down the walls. So, and in term of this construction, we did a refurbishment of the old house as well, as we insulated the house better, the older house better. So because it doesn't make sense to build a new house, an efficient house, and leave the old house by the old use. So
Right.
we did it in fact altogether refurbishment of the old house and building a newer efficient part of the house.
How old was the old house?
Oh, it's pretty old. It's like built pretty close after war, I believe. So
Okay, so in that category of the
before
refurbishments people want to
absolutely
see.
in the category, yeah.
All right, and what did you? Okay, Windows 2. Was that part of the refurbishment? So
Windows was earlier actually.
Okay, so
so
there were
the
already
old
better
house
windows.
was
Okay.
already better Windows.
So now
yeah.
the whole house is up to a better standard.
Right.
Do you notice improvement in comfort.
Absolutely.
Yes.
Absolutely, yeah. Because in the old house you had to crank in the heat and it was going away like instantly. So when you insulate it, you got this pretty good comfort feature by leaving the heat in the house.
Right.
It doesn't get away that far.
So your family spent a lot of money to do this, but they also got a bigger, better house.
Yeah.
More modern house, more comfortable house.
Yeah.
And they can use less energy.
Right.
All right. Do you know what happened with the boiler? Was there a boiler in there?
There is a boiler in there, yeah, and it was left in there.
Okay, so they kept the same boiler.
Yes.
That's the thing about boilers; they last for ages,
Yeah,
and you've got all those radiators already.
Yeah.
Yeah. So I think that leads us to an interesting question there, because we need a disruptive discovery to take to the boiler company, and we're going to travel to the future and look at, okay, so the Wärmewende has been successful. The houses in Germany are at the passive standard, or they're cold, basically. There's no oil or gas 100 years in the future. Yeah. Your house is still there, Philip. Is that nice to know?
Probably.
Marianisplatz is still there.
Yeah.
Isar River's still there.
Yeah.
The English Garden's still there. We still got beer gardens.
Pretzels and beer.
Pretzels, beer.
Yeah.
It's all good. Yeah. But we have had this massive refurbishment. And the other thing we notice is that even with all the refurbishment, there still isn't enough fuel for people to use fuel the way that we use it now. Just sort of use whatever you want.
Yeah.
What we see is that people have a store of wood pellets. That's what they have for the winter, and then that's what they have. And so they're managing their use of that fuel. They make decisions about maybe holding some back for those cold spells in February. Maybe it's not that cold, and they're basically working within a constrained amount of fuel. But it works. They're fine. They're comfortable. Munich's a great place to live.
Yeah.
And the forests are being managed sustainably. The only way to have that sustainable forest management is that you can only use what there actually is.
Yeah, of course.
For sure.
Yeah, and Germany isn't causing the deforestation of other countries either, just to note.
Yeah.
So, because everything, yeah. So that leads us to the discovery of an idea for what our boiler company is going to be making in those years. We've got, like we said, a lot of apartments, and those apartments really do have these whole systems that they can use waste heat from other things in the city. That's called the district heating. They can use one boiler to serve a whole lot of apartments.
Yeah.
We've got single family homes that have their own boiler. We don't know in the passive house if there's really boilers there. There might be solar hot water, and people might not take quite as many showers in the winter. But what we see is that today, to go onto that pathway that leads to that future, there needs to be a new kind of boiler control.
Yeah.
For sure.
And that's what we discovered, and we're going to tell you about it. And the key idea is that it's a smart operating system for your boiler. We talked about how boilers right now, the operating system is not smart. It just cranks out heat, which is fine, but not smart.
Yeah.
So we think that it's possible to develop a new kind of boiler control that lets you set a target for how much oil or gas you are going to use and stay within that target. And we think that can be monetized.
Yeah.
That you could get a bonus at the end of the year if you make that target.
Yeah.
Because you've reduced carbon emissions.
Yeah.
So you could be part of the carbon economy there. And we also think that what would it take? It would take some sensors in the house, some programming logic. You would definitely need to do a research project to develop this boiler control. But you could use sort of a machine learning that the boiler could use to decide when to turn on and off, besides just lots of heat all the time.
Yeah.
Yeah, not using the oil more efficient, but smarter. And
Yeah, because the boilers, a lot of them are already quite efficient.
Yeah.
And
actually,
so this product that we've got in mind, the company could actually develop this smart controller in a way that it could be retrofitted to their existing boilers.
yeah,
So like for your dad's house might be
right.
a good test case.
Absolutely.
Because the thing we're thinking is that if you looked at the time constants, the transient behavior of the building, it would tell you a lot about what people are doing and what the weather's doing and what the thermal mass of that building is doing. And I think you could avoid a lot of those overheatings. I mean, I have to confess, when I cranked up because I was cold and then later it was too hot, I actually opened the window
Yeah.
because it was too hot and I let the
Yeah.
heat out.
So-
That's horrible. I felt bad when I was doing it.
Worse.
Yeah.
I think we could avoid that
Yeah, of course.
with a
you
smart
can.
boiler controller.
Yeah.
So that's our big idea. We now have to look at that and go, okay, if in the culture people started, like, just part of their culture was to decide what their set point was going to be for that year.
Yeah.
You would have the experience of the previous year.
Of course.
You would know that, you know, like if you had a new baby or somebody got sick, that you could
Change.
yeah, you could change it, but you want to try and meet a target. And there's a benefit to meeting that target, and you're part of that solution. That you're part of that transition. We think this is really a transition technology.
Yeah.
So we're thinking of proposing it to a company and working with the university here to develop it.
Mm-hmm.
Yeah, why not? Because we think it does lead to that transition. It leads to a behavior, a way to use less fossil fuel, a way to still meet your needs but not be wasteful, a way for a company to be part of the transition with the technology that they now have, that just like when they first started making these boilers for water, it will give them the experience that they need to work on the next technology.
Yeah.
And we also thought if we were going to advise a heating company right now, we would advise them to get into new designs for wood pellet cooking.
Mm-hmm. Mm-hmm. Yeah.
Because we think when you do a passive house redesign, you might be looking to reuse your old boiler like your father did. But when that gets to its end of its life, you realize you really didn't need that whole big old boiler, and
Yeah.
you could do the job with just a cooking system.
That's right.
For sure.
And as we start to reduce the amount of gas for heating, we're going to need to be looking for the next place to reduce the gas, and that'll start to bite into cooking. So there we go. We think we've come up with something disruptive, and the key to that disruptive idea is the constraint of saying, I'm like my wood pile out behind the house, that's how much wood I've got, and I'm going to watch how much I've got, and I'm going to make decisions about what I want to do based on that, and I'm going to be involved in deciding how much to use, even though it's actually a smart boiler system that's helping you make those decisions, so
That's
to speak.
true.
Letting you track how much you're using and see how close to your target is.
That's the idea. Yeah.
Yeah,
It is.
I think it could work.
It could.
Pretty exciting.
Yep.
Yeah.
A lot of work for us.
Well, that's all right. I mean, it's real work, right? It's something that you can actually do. And as you start to think about, okay, what kind of measurements would you need? What would the processor be like? What would
Yeah.
the experiments be that you'd want to set up? The company would want to use the information about how their old boilers that are in place are operated, what's their operating system, maybe some of their older ones, they don't want to go through developing it for that one because it's going to be more effective to replace them. But what we're doing is we're actually affecting that transition. We're enabling it.
Yeah.
And that's the point. So we had a wicked problem before, and now we've got something we can work on that makes sense. It wouldn't cost that much. You could do it. It would be part of the transition. We're pretty happy right here in Munich today.
Yeah. It's a good day.
All right.
Yeah.
Well, thanks, guys, and thanks for being with us for this little example. Definitely feel free to contact me if you want more information about it or find out what happened with this. See if it's now a project in Munich at the university.
Let's
Yeah.
hope.
All right, but there's a quick run through. Actually, I should make a disclaimer. We've given you the results of that project. We actually spent a few weeks on it.
Yeah.
Yeah.
It's not an instant thing. Being able to do that kind of project is just like any other engineering. You have to gather the data, you have to do the modeling, you have to do the brainstorming. But we did have a successful result.
Right.
So we thought we'd share that
Right.
Yeah.
for inspiration.
Absolutely.
All right, thanks guys.
Thank you.
We'll see you next time.
See you soon. Bye bye.
Bye.